passenger's weight at T equals 1.
Okay, elevator problems are really weird, but alright.
Shows a velocity graph, 75 kilograms passenger elevator.
Okay, so this is velocity. And apparent weight, what does that deal with?
Apparent weight.
Yeah, so apparent weight was like, that's a force, right? So when we were talking about weight, we were talking about forces. So,
T equals 1.
so what good does a velocity graph do us if we're trying to find forces?
Nothing.
What do we need to find in order to find forces?
Find acceleration.
Yeah. So using just this graph, at that point, how can we find acceleration from a velocity graph?
Acceleration.
So you remember doing all the graphs at the beginning of the class where you'd have like a position graph that went like this, and you'd find the velocity graph and it would look like this.
Yeah.
And the acceleration graph would look like this. So what was the relationship there? How are we finding?
Oh, okay. So it would be positive, right?
Yeah. So the slope right here is your acceleration at t equals 1. So what's your slope? So I don't have it written on here. I just have, so whatever you got on here.
75 kilograms.
So don't worry about the mass right now. I'll just try to find the acceleration from that graph.
So it'd be like at 1
Mm-hmm.
right here.
What's the slope right there?
It's positive. So 2.
So we don't know what the value at 1 is, right?
Right.
But we do know at 2, it's going to be 8 up here.
Yeah.
So, and then this is just a straight line. So if at 2 it's 8, what's your slope going to be if you use rise over run?
So it goes.
So how far up has it gone in 2 seconds?
8
Yeah.
over 2.
Yeah.
4.
So your slope is 4. So that means the slope right here is 4, the slope right here, and the slope right here, and the slope at 1, which is what you're looking for.
Oh, the one's at 4.
Yeah. So what's your acceleration?
4.
Yeah. Okay. So then you know mass times acceleration.
Do 75 times 4.
Okay. 300. So what does this have to do with his apparent weight?
His weight.
So if we were to look at his free body diagram, what would be going on? He's in an elevator. So what forces are acting on him?
Gravity.
Yep, force of gravity. Is this, well, yeah, let's get the other forces and then we'll talk about this. Force of gravity. And then what force is pushing him up?
Normal. Well, tension.
Well, yeah, so for the elevator, you've got a cable here that's tension. But for him standing inside the elevator, it's just the normal force of the floor of the elevator. So you've got this normal force. Which one's greater?
Normal force.
Yeah, by how much? What if we sum the forces in the y? You'd have
Normal force minus gravity.
and this time it's not equal to 0, this time it's equal to force equals ma,
Oh yeah. Mass times acceleration.
which we found over there. So this is 300. Well, what's the force of gravity on somebody with 75 kilograms of weight, or a 75 kilogram mass? It's going to be mg, 75 times 9.8.
That's
735 newtons. I think. Okay, so then you have normal force minus 735 equals 300 newtons.
okay.
So what's your normal force?
735 plus 300 is 1,035.
All right, so this is the normal force. That's how much is pushing up on him. So if he were standing on a scale in the elevator, that's how hard the scale would have to push back to keep him accelerating up. So that would be, because there's like the way a scale works is you stand on it, at least like spring scales and stuff, they're a little bit different now with digital scales, but you'd step onto it and the spring would compress.
Right.
So now this spring force that's pushing him up is the normal force. So if he was standing on a scale in the elevator, that spring force would go up and it would seem like he weighed this much. Does that make sense?
Yeah.
So like, you know how when you're standing in an elevator and it starts accelerating up, you feel like you're pushed down into the ground. You feel like you're heavier. That's what's happening, is because you're accelerating upwards, there's a net force here. So your normal force exceeds the amount of gravity, or the force of gravity on you. So you feel heavier than normal. Because like right now, when we're just standing around not accelerating up or down, the normal force from the floor acting on me is exactly the same as the force of gravity acting on me. They're the same.
Gotcha.
But if I start accelerating in one direction or the other, then it's different. So what would his apparent weight be if the elevator... Well, actually, I think that's the next question. Maybe.
Current weight at T equals 5.
Oh. And then is there a part C?
Yeah.
Okay. So T equals 5. That'd be in here somewhere.
Yeah. So 8. Well. It's the same.
Yeah. So there,
Just-
this will equal 0. Make this equal 0. So then normal force would just be the same as gravity. Okay. And then when you start going down, what happens to your mass times acceleration?
It goes down.
Yeah, it'll become negative, right?
Yeah, it's negative.
So you find your acceleration, which would be negative, using the slope. You plug it in mass times acceleration. You put that over here. Then because it's negative, say it was negative 100, it won't be, but say it was. Then when you add the 735 over, you get 635. So then that would be your apparent weight. So that's kind of what it's talking about. As the elevator accelerates to lift you up, you feel like you're heavier.
Right.
And then right when you reach the top, it starts to slow down. And you start to kind of feel that like weightlessness. So the same thing happens on like a roller coaster, you know. You start at the top and it starts accelerating down. So there's a net force going down. So that means that your free body diagram would start looking like this. So your apparent weight becomes pretty small. And then once you hit the bottom of the curve and it starts pushing you back up,
Changes.
gravity is exactly the same, but then it's pushing you up, so you start accelerating up. So that means your normal force becomes much larger. And your apparent weight is this. So that's how it works as you're on like a roller coaster. That's why at the very top, you start to feel weightless as you go down. And then once you hit the bottom, you feel like you weigh 500 pounds or whatever, and you just push down into your seat. It's all physics.
It's cool.